Hello everyone, my name is Justin Feralis, and I did my materials project on fan blades and jet engines. So fan blades are usually made from titanium alloys, or in some cases nickel-based superalloys, and the fan brings in a large volume of air. So 90% of this air goes straight through the back of the engine, and that is known as bypass air, and that provides 75% of the engine's thrust. The rest of the air travels through the engine, so it goes from the fan blades into the high pressure compressor and the low pressure compressor where the air is compressed. And in the combustion chamber, the energy is created from the compressed air and jet fuel, and that is expelled through the high pressure turbine and the low pressure turbine. And that's where or that's where 25% of the engine's thrust comes from.
I chose this topic because my major is aerospace engineering, and I just wanted to know how thrust was produced inside of a jet engine. The fan blade's function, as I stated earlier, is to bring in large amounts of air. So fan blades must be stiff, strong, and have toughness, as debris such as birds can fly into the blades during the flight. The planes usually fly at an altitude of 40,000 feet with temperatures that are around negative 70 degrees Fahrenheit. So the fan blades must be able to operate at those temperatures, as well as resist corrosion and oxidation at low temperatures. For the objectives, the fan blade must be light and strong, because heavy blades require more energy to move and require more fuel. For the free variables, it's just the choice of material. So here's my screening slide, and on the left I have my constraints from the previous slide. And the only ones I wasn't able to put into the material selection software was the high resistance to creep and the corrosion resistance. And but I was able to put in all the other constraints into the limit tree. And the materials that passed those constraints was nickel, nickel-based superalloys, stainless steel, titanium alloys, and tungsten alloys. So here's my ranking slide, and the material index I used for the ranking was tensile strength over density. And my first place material was titanium alloys. And as you can see on the graph, it had the lowest density with a relatively high tensile strength. And my second place material was nickel-based superalloys. And my third place was nickel and stainless steel. Because it was a tie because they both had the same material index. And in last place was tungsten alloys, just because it was way too dense to be a fan blade. So here is some documentation about titanium alloys. So Ti64 is the most used titanium alloy and is commonly used in fan blades as well. And they are constructed of 6% aluminum, 4% vanadium, 0.25% iron, 0.2% oxygen, and the rest of it is titanium. And as it says in the documentation, it has the highest strength to weight ratio of any structural metal, which is beneficial for fan blades. So here is some more information about the properties of titanium alloys. It has a low density compared to the materials that pass the screening process. It has a high Young's modulus, a high yield and tensile strength, and a high factory toughness. Titanium alloys can operate at really low temperatures, and in the design guidelines, you can see it has a good resistance to corrosion and a good resistance to creep. They are durable in cryogenic temperatures and are durable to water, which is beneficial because planes can occasionally fly in rainy weather. Although titanium alloys are more expensive than nickel-based superalloys, its strength to weight ratio is just more favorable. And titanium alloy fan blades and nickel-based superalloy fan blades are manufactured the same way. They're manufactured by superplastic forming and diffusion bonding. And both titanium alloys and nickel-based superalloys have excellent resistance to corrosion, and titanium alloys and nickel-based superalloys have similar carbon emissions. So titanium alloys are just better because they have a better strength to weight ratio, and that is more favorable in fan blades. So in conclusion, titanium alloys ended up being the best material for the job, and for this project, I used the Granta material selection software, And my top material did end up being what is generally used in jet engines. And this is relevant because planes are used daily around the world. And some things I did not expect was for nickel and tungsten alloys to make it past the screening. And if I had more time, I would specify the values for my constraints more. And that is it. Thank you for listening to my presentation.